This is r.d. Sharma Solution Class 12, Chapter 19. Exercises 19.19 Indefinite Integrals. Now in this exercise, we will be using all the logic reasons which we have seen in the previous questions and previous exercises. So we'll use the partial fraction kind of thing in order to complete this exercise, because this will be in use for all the questions which are coming up. So just understand this question very carefully so that you are competent enough after this exercise to solve these questions. X square plus 3x plus 2, the denominator has to be done in such a form so that we get the numerator. What does it mean? It means just represent the denominator in the form of numerator, but in terms of differentiation. That is, x I am equating and trying to get a constant a with a differentiation result of x square plus 3x plus 2, which is in this case the denominator. Then we add one more constant because some constant is going to come. Now this a and b, if it comes, then x can be represented in this form, and then we get two separate terms which can be integrated easily. So now d by dx of x square plus 3x plus 2 is 2x plus 3 plus b. Now the only thing is you have to equate the similar terms on left and right. X is equal to 2ax plus 3a plus b. So this x can be equated. There is 1 in front of x on the left. There is 2a in front of x in the right. What is the counterpart 3a plus b on the left hand side? It's 0. There is no constant. So that is how we will equate the similar terms. That means 2xa is equal to x left and right, and then 3a plus b is equal to 0, of course. What are you going to get? X gets cancelled. You will get a is equal to 1 by 2. When you put this a equals to half in this, 3 into half plus b equals to 0. That is, b will be equal to negative 3 by 2. Now we got a and b. We will replace it in this equation, which is I am indicating as 1. So x is now, after all this procedure which we have done, x is equal to 2x plus 3 and half, because a was half, a has come as half. Then we have negative 3 by 2. Now this x can be represented like this. So what will be the integration now? I'm writing the integration in terms of what we have got. So this will be a into 2x plus 3 plus b. A is half into 2x plus 3 minus 3 by 2. This x whole. A is half, b is negative 3 by 2. So I'm separating these two terms. I'm just trying to minimize the step. So negative 3 by 2 dx divided by what will come? X square plus 3x plus 2. Of course, it will be in the denominator. Numerator we have separated. Half 2x plus 3 one term, negative 3 by 2 another term. So the first term is quite easy because it's a direct differentiation of the denominator. So let me call it this I1 and I2. We will separately integrate them and then we will integrate them. That is, we'll combine them together. So I1 is, we can take this half outside. This x square plus 3x plus this one, the denominator. If you take it as 2, dt by dx will be equal to what? We have already differentiated it. It was 2x plus 3 if you remember. So this dt by dx is 2x plus 3 and that is in the numerator. So dt will be equal to 2x plus 3 into dx. So 2x plus 3 can be written as dt. The denominator was taken as t. Half is already outside. So it's simply integration dt by t, which is log t, modulus of t. So half log modulus of t plus constant of integration. Let me call it as constant of integration c1. So what was t initially? X square plus 3x plus 2. Let me write this now. Plus constant of integration, call it as c1. What about I2? Which is the second part, or second term. We'll deal with this negative 3 by 2 later on. X square plus 3x plus 2, if it is a perfect square, it's okay. Otherwise, you need to make it as a perfect square. X square plus 3x plus 2, you need to take 3 divided by 2. 3 by 2 will come, square it, add it, subtract. So I'm adding 3 by 2 whole square and subtracting 3 by 2 whole square. So a square plus b square plus 2ab, which is x plus 3 by 2 whole square. This is a plus b whole square. 2 minus 3 by 2 whole square is what? It's 2 minus 9 by 4. So 8 minus 9 by 4, which comes as negative 1 by 4. So negative 1 by 4, that is 1 by 2 whole square. So we have got the perfect square now. X square minus a square integration, that is in the denominator, we already know the result. Please remember, there is no under root in the denominator. It's simply x square minus a square which we are going to get. So let me write the formula in order to just make you recall that simply 1 by 2a log x minus a by x plus a, which are included inside a modulus sign. So same thing I'm going to do here. Let me write it here. I'm not dealing with the constant right now, but dx by x square plus 3x plus 2 can be written as dx by x plus 3 by 2 whole square minus half whole square. So x plus 3 by 2 whole square minus 1 by 2 whole square. We have the direct result, which is 1 by 2a. 1 by 2 into a is 1 by 2 log x minus a by x plus a. So x minus a is what? X plus 3 by 2 minus 1 by 2. So x plus 3 by 2 minus 1 by 2 and x plus 3 by 2 plus 1 by 2. And this will be inside the modulus sign. And I'm calling this c, which has come from this I2 as c2. So let me just write it like this: log x plus 3 by 2 by plus minus 1 by 2. 3 by 2 minus 1 by 2 is 2 by 2, that is 1. So you can just write it as x plus 1. Denominator is x plus 3 by 2 plus 1 by 2, that is x plus 4 by 2, which is x plus 2 plus constant of integration. Now this is I1, this is I2. I2 is preceded by negative 3 by 2, but we are going to combine them and write the final result. So I was having I1 and I2 for you, and let us recall what we have got in I1 and I2 and we'll combine them. So half log modulus of x square plus 3x plus 2 and then negative 3 by 2 log x plus 1 divided by x plus 2. And since we have C1 and C2 we got from C1 I1, C2 I2, we can just combine this C1 and C2 and get a constant of integration, which is capital C. That's your final answer. So whatever we have discussed is in the step-by-step form in front of you. We have used the partial fraction kind of thing, and then we separated this into two terms and we integrated them separately and just joined them. Now you are aware from the first question, we can do the same thing here. X plus 1, the numerator, can be written as the differentiation of the denominator, which is preceded by a. So d by dx, x square plus x plus 3. Then we have the constant b. d by dx is what? A, it's 2x plus 1. What is b? We don't know yet. X plus 1. Now let's equate, but before that we have to multiply this 2x plus 1 with a. It will give you 2ax plus a plus b. So 2ax is equal to x, that is the similar term we are equating. 2ax equals to x. As the previous question, we get a equals to half. A plus b will be equal to 1. So a is half. Now write this half here. Half plus b equals to 1. B will be equal to 1 minus half, that is going to come as half. 1 by 2. A is half, b is half. So we can write this x plus 1 equal to half x, this differentiation 2x plus 1 plus, what is this? Half. Now we have, let me write this, in place of x plus 1, we have to write half into a 2x plus 1 plus half. That's what we have to replace, and then we will separate this two terms. So this x square plus x plus 3 is already with the first term. Now I am writing it with this another term also. I am doing it here only. So half will come in front. That will be done with the first term also. And x square plus x plus 3 will come here. So I have separated these two terms. That is a into 2x plus 1 is the one term. B is the other term. And a and b we got. So half I am just picking up and taking it in front of integration. So we don't want to deal with the constant until we have got the final answer. So we'll deal with this half later. The I1 is what? X square plus x plus 3, you can take it as a t. When you take t equals to x square plus x plus 3, dt by dx will be equal to 2x plus 1. We have already differentiated it. So dt will be equal to 2x plus 1 into dx. That's what we are going to take. 2x plus 1 into dx, the numerator is already dt. The denominator we have taken as t, x square plus x plus 3. So this is simply log t. Log modulus is very important. Log x square plus x plus 3, because t was x square plus x plus 3, because integration of dt by t or dx by x is log x or log t. Now we have to add a constant of integration, which is c1. I1 we have got. Now this I2 is what? Dx by x square plus x plus 3. So dx by x square plus x plus 3, let me write it as x square plus x plus 3. We have to make it as a perfect square. What is the coefficient of x, which is 1? Divided by 2, it will be 1 by 2. Square it, 1 by 2 whole square. Add it, subtract it. So I'm adding and subtracting 1 by 2 whole square to this term. What are we going to get? X square plus half square plus x is x plus half whole square. So x plus half whole square. Integration is like this. What is another term? 3 minus half whole square. So 3 minus 1 by 4 it will be. So this will be 4. This is 12. 12 minus 1 by 4, which is 11 by 4. So we have to make it as a perfect square. So 11 is not a perfect square. 4 is, of course it is. So we have to write under root 11 by 2 square. So under root 11 by 2 whole square is the another term. So x square plus a square integration in the denominator, you already know this. What is the result? It's 1 by, let me write the formula and then we'll just put these values. Integration of dx by x square plus a square is going to be 1 by a tan inverse x by a. What is x here? X plus 1 by 2. What is a here? Under root 11 by 2. So 1 by a under root 11 by 2 tan inverse x by a. X is x plus 1 by 2. So x plus 1 by 2. And this is under root 11 by 2. So I'm solving this now. This will be 2x plus 1 by 2. Under root 11 by 2 is here. 2 gets cancelled. 2x plus 1 by under root 11. 2 goes up. Under root 11 goes down. So tan inverse 2x plus 1 divided by under root 11. This is under root 11 now. And with the constant of integration, let me call it as C2. I have not combined these two terms. So now the final thing is I1 plus I2 we have to do. But before that, just recall half was already there, constant. I told you that we will discuss it later. So just include this half and write these two terms. Log x square plus x plus 3 is the first term. Multiply this with half also because half is already in front of both the terms. 2 gets cancelled. 1 by under root 11 will come. And then this will be tan inverse 2x plus 1 by under root 11. And C1 plus C2, what are we going to get? Just call it as some constant C. Call it as capital C. So this whole which you are witnessing is the final answer. So whatever we discussed is in front of you. I hope you'll be able to solve it. We have done 2 questions like this. And now the whole exercise is all about these what we have done just now. So to separate these two terms, differentiation of the denominator will give you numerator. Next stage x minus 3 by x square plus 2x minus 4. So we have done the 2 questions in great detail. So x minus 3 can be written as the form of differentiation of the denominator. So a d by dx of x square plus 2x minus 4 plus capital B. This a and b are simply constant. You can call it as p or q also. So x minus 3 is equal to a. Differentiation of x square plus 2x minus 4 is 2x plus 2 plus capital B. This will be 2ax plus 2a plus b. Now equate it with x minus 3 and equate the similar terms. 2ax will be equal to x. This will be the first equation. And 2a plus b will be equal to negative 3. That's your second equation. So from here again we have got a equals to 1 by 2. Now put it here. 2 into 1 by 2 plus capital B equals to negative 3. 2 gets cancelled. 1 is there. So b will be equal to negative 3 minus negative 1, which is negative 4. A is half, b is negative 4. Now put it in the equation which is the second equation, which I have written. So this x minus 3, the numerator is now can be written as, this is what I was talking about. It's half 2x plus 2. The denominator is what? This one equation I'm using. Denominator will be x square plus 2x minus 4. Let me write it here only. And the second term will have a numerator as negative 4. So let me write this equation first so that I can show you how we separate them out. So x square plus 2x minus 4 will remain in the denominator. Now I'm separating these two terms. So half will come outside. 2x plus 2 will be in the numerator. X square plus 2x minus 4 is the first term. The second term is 4, which we have taken outside. Dx divided by x square plus 2x minus 4. So these are the two different I1 and I2 you can call it. And this we are integrating. This is I1, this is I2. So let's do this. I1 equal to what? X square plus 2x minus 4, take it as some t. Differentiate this, dt by dx will be equal to 2x plus 2, which we already got. So 2x plus 2. Dt will be equal to 2x plus 2 into dx. So this, what you got, is a dt, integration of dt divided by t, of course. X square plus 2x minus 4 was taken as t. It's log modulus of t plus some constant of integration, call it as c1. So log, what was t? It was x square plus 2x minus 4 plus constant of integration c1. Now let us move towards I2. I'm not dealing with negative 4 right now. I'm just dealing with the integral part, which is dx by x square plus 2x minus 4. X square plus 2x minus 4 has to be made as a perfect square. For that, the coefficient of x is 2, divided by 2, you will get 1. Square it, it will again be 1. Add it, subtract it. So I'm adding 1, subtracting 1. A square plus b square plus 2ab, x plus 1 whole square is there. Negative 4 minus negative 1 is negative 5. You cannot have a perfect square for that, so root 5 whole square. So I'm writing this as x plus 1 whole square minus root 5 whole square, which is in the denominator. And you know already the formula integration of x square minus a square. We have already seen it, but just to recall so that it feeds into your mind, it sticks into your mind, dx by x square minus a square will be 1 by 2a log x minus a by x plus a. But it has to be included in the modulus sign. So log modulus of x minus a by x plus a plus constant of integration, call it as some c2. So I'm writing the final answer 1 by 2a, a is root 5 here. Then log x minus a, x plus 1 minus root 5, x plus 1 plus root 5. That will be the numerator and denominator. So let me just write it here because there will be no change. So directly x plus 1 minus root 5, x plus 1 plus root 5. This is inside the modulus sign plus constant of integration, which is your c2. Half is already there, so multiply it there. Negative 4 is there, so multiply it by negative 4. I'll just put a negative sign. So I'm writing and combining it. I will be equal to I1 plus I2. If you remember, in the previous questions also we have done the same thing. This is the first term. We already multiplied it by half. So half log x square plus 2x minus 4 plus constant of integration. I'm not writing it because I will be combining c1 and c2 into a constant term, which is capital C. Minus 2 by root 5, because this is what we got after multiplying 4. Log x plus 1 minus root 5, x plus 1 plus root 5 modulus sign. C1 and C2 will give you C. So this will be C. So this is your final result. And this is the way you are going to go about it. This is the whole procedure you have to follow. If you understood previous two questions, this will be very easy for you. But we will be doing the other questions in greater detail so that these all solution gets into your mind and you'll be able to solve whenever you want. This question will be taken in the next discussion. Till then, thank you so much and have a good one.